Question number 14. Four objects like 4 objects of equal mass rests on a table. Okay, this one is your table and there are 4 objects. The center of mass of each object is labeled G. Here, this G represents center of mass, center of mass, and center of mass. Which object is least stable? We are going to find out the least stable object. So for stability, we know that the object with large base area and lower center of mass is more stable. Okay, now you can see like it's very simple to guess. Like the B has like the base area of B is, you can see the base area of B is the smallest one among all of them. Second thing, like center of mass, this one may have lowest center of mass than this one, then this one, and the B has highest center of mass. So the B is actually the contradiction of stability. The position of B, like its center of mass and base area, are totally against against the requirement for stability. So that's why this one is the least unstable. The most one may be this one or this one, and then we can expect them. But the least one is B. Our option for least stable object is B. The reason is its base area is small. Its base area is small and its center of mass is high. The diagram shows a uniform balanced beam pivoted about its center. So pivot is here at center. It means here and here the lengths are equal. What is the value of force P? P is somewhere here. Okay. So let's consider the movement generated by each force. This force is acting in downward direction and possibly it is looking to create a clockwise movement in this rod, balanced beam. And this force is in upward direction and possibly it is going to create a clockwise movement in it. So there are two forces which are acting in such a way to create a clockwise movement. And there is one more force which is acting in downward direction here, which is about to create an anti-clockwise movement in it. Like this, it is creating an anti-clockwise movement in it. So we have one force which is creating an anti-clockwise movement. The red one is creating an anti-clockwise movement, and the two greens are supporting each other to create a clockwise movement. So by law, we know that clockwise movement, sum of all clockwise movement and anti-clockwise movement for a stable object are equal. Okay. So actually the condition is mentioned, I just forgot. Here is a uniform balanced beam. When there is a term balance, it means it is Like clockwise movement and anti-clockwise movements are equal. So clockwise we have two movements. 4 Newton force is acting at 2 centimeter distance plus P force is also acting at 2 meter distance, 2 centimeter distance. Then we have then we have 3 Newton force acting at 6 centimeter. So at the right hand side we have 18, and on the left hand side we have 8 plus 2p. So 2p would be equal to 10. 18 minus 8 would be 10, and p would be equal to 5. P is a force, so that's why it would be in newtons. So the correct option would be 5 Newton, like this. Okay, number 16. The diagram shows 4 shapes cut from the same piece of card. Means their densities, when the material is same, it means their densities are same. Which shape has the center of mass nearest to the baseline? Here is the baseline. Okay. I think it's C, because it's most of the mass is concentrated in lower region. So there is a possibility that its center of mass would be in the lower region. Yes, I think so. Okay, let me check. Yes, this one would be most probably. Number 70. The mass is X. Here is a X mass, and Y mass are placed on opposite side of the center of uniform rod. Here is a center which is pivoted at center. Okay. Which combination of masses and distances balances the rule? Okay. So this weight is going to act in downward direction. So it is looking for a clockwise movement. The weight of this block is going to act in downward direction like this, and it is looking to create an anti-clockwise movement in it. So if it's a balanced one, then X is the weight, P is the distance. So X time P and Y time S would be same. So let's check which one is correct. So X times P and Y times S. And we know that, oh, okay, in a table, we have masses. So we need to put G as well, because it would become weight, and it would become weight. Then G is automatically cancelled, so we can directly put X times P equals Y times S. So now let's multiply. X is 200 and P is 5. So 200 times 5 is 1000. First option is 1000 here, and on the right hand side 200 times 10, which is 2000. So these are not balanced. So this option is not possible. Let's move to the second option. In second option, X times P, it is 200 times 10, which is 2000. And on right hand side, it is Y times S, 300 times 15, it is 4500. Still, it is not balanced, so this option is also incorrect. Let's move to the third one. So we have 400 times 12, which is 4800. And then we have 300 times 16, which is also 4800. So these options are gives the similar type of movement. So we can consider this option as the correct option, but we will check the last one as well. Okay, 500 times 15, it is 7500, and 200 times 30, it is 600. So this option is also incorrect. Number 18. That a student balances a non-uniform object on a pivot, like this is the balancing point. To do this, a weight is suspended near the left hand side. Okay. Where is the center of mass of the object? Okay. Center of mass of the object. Okay. Suppose this object is absent. Then it looks that there is a kind of clockwise movement in it. That's why the student put some mass here to balance it. It means center of mass is not this point, because it is not the balancing point. Center of mass is a point where the whole object can be balanced. So it means C is not the balancing point. And A and B are already not balancing point. So we are left with only one option, which is which is D option. Because you can see, to consider C as a pivot point, you need some extra mass here to balance this mass. It means more mass is here than on the left hand side. So that's why it looks that B would be the center of mass. An object Y is in a fixed position on a rod. Y is in a fixed position, okay. A rod X is moved, like you can move X to this side or this side, in both sides. Moved, and the position of a pivot is adjusted until the rod balances on pivot. Like here is a pivot point. You move X here and there to balance this beam. The experiment is repeated in a region where the gravitational field strength is lower. Gravitational field strength is lower. What is done to keep the rod balanced? Okay. So let's talk about the physics behind these two. The weight of it is acting in downward direction. It is, okay, 1 second. So possibly the Y is looking to create some anti-clockwise movement. And if we just look at X is looking to create some clockwise movement in it. Okay. Y, on Y side, there is a anti-clockwise movement. On X side, it is clockwise movement. Okay. From the figure, we can see the mass of Y is larger. Like if there is a lower gravitational field, then it doesn't matter, because for Y and X, like for X and Y, both of them will have same gravitational field. That's fine. So if this distance would be small, it means a small anti-clockwise movement would be there. And if the distance would be large on this side, would be large, then you can have large clockwise movement, because mass is small. In order to compensate the difference of mass from as compared to Y, you need to increase the distance. Like movement is force into or weight into perpendicular distance. Right now we are talking about distance, weight. So for the case of X, its weight is small, so its distance from the pivot should be large. So for that reason, in order, like suppose the pivot, we can fix pivot here. So this distance would be small and mass would be large. Small distance and large mass. And here we have small mass, so we can create a large distance by moving this X from here to here. Or even we can move, if we don't want to move this one, we can move pivot to this side to decrease the distance and increase. But the possibility is that if we keep pivot on a single position, we don't move it, like we are not willing to move. So there is no there is no movement of pivot, and We can move X to the right side to increase the clockwise movement. So by moving it to the right side, we'll create more clockwise movement. So we can easily balance anti-clockwise movement. So I think so the possibility is this one. Okay. For solid shape, four solid uniform cones have equal weight. They are placed on the bench as shown in the scale. Which cone is most stable? So we know that the two basic conditions for stability, if the base area is large and if center of mass is lower. So it can be easily understand from the figure that C has the largest base area, and it looks that its center of mass is also lower because its height is small. So it means its center of mass would be somewhere here. Its center of mass is expected to be here. Its center of mass is expected to be here. So so it looks that C has the lowest center of mass and largest base area. So C would be the most stable one among all of them.